So, when developing new drugs and pharmaceuticals to treat diseases, obviously human subjects would be physiologically the best option to figure out how these drugs are going to work to treat specific diseases. But that is almost always not applicable, at the very least in the early stages of medication development, so you gotta find other ways to do that. Because, ethics and all that, you can't just be testing random drugs on humans without knowing that it's safe first. So, kind of the two next best options are either cell cultures or animal models. Now, cell cultures are a little bit more ethical, usually, ignoring the whole Henrietta Lacks thing, which I've talked about previously, but sometimes they don't work that well as a whole system because often cell tissue cultures are only a one or two different cell types, so they don't show how they work in the entire body. So that's where animal models would be the best option. Now, of course, it would be optimal if you could avoid animal testing altogether, but unfortunately, it just at this point cannot be avoided because sometimes tissue cultures are not the best option, and you, again, can't use human test subjects without it being proven safe at least a little bit. So one of these areas of research that uses animal models is Alzheimer's research. And there are quite a few different animal models used, including mice and rats and guinea pigs, as well as sometimes apes like chimpanzees. But the so far best animal model, or one of the best, is not the animal you would expect. This is the common Degu. It's a type of rodent that's native to a bunch of areas in South America, more specifically the Andes mountain range. And they have weirdly similar Alzheimer's progressions as seen in humans. Kind of the epidemiology and progression of Alzheimer's in the Degus is very, very similar to how it works in humans. It has pretty much all of the, it has very similar stages. Like, Alzheimer's is different in kind of every individual case, but overall, it does have a very similar progression. And even more interestingly, physiologically, they tend to respond to Alzheimer's drugs in very similar ways, which is interesting because we are not that closely related to these Degus other than both being mammals. So due to this weirdly similar pathology of Alzheimer's in humans and Degus, they are often a very good model to use. However, there are still some drawbacks. Like with everything, they're not the perfect model. Again, ideally, the perfect model to test and study these drugs would be humans, but ethically, we cannot do that. So the Degu do tend to be quite commonly used, but they're not the most common. That tends to still be mice and rats due to the fact that Degu are, in terms of rodents, quite long-lived. In captivity, they can live between 5 and 8 years, and they do have quite a longer maturity point than mice do. It takes quite a bit longer for them to reach full maturity, which makes studying them a bit of an investment because you have to keep them around quite a bit longer than mice. They also develop Alzheimer's decently late in their life, between 2 to 6 years into their lifespan, which again means it's a bit of an investment because you have to keep them around and keep them alive and healthy and happy for long enough for the Alzheimer's to start to develop. So mice are a lot easier to use in terms of lifespan. They tend to naturally live a quite a bit shorter lifespan, they reproduce faster, and they develop Alzheimer's a lot earlier, so it's less of an investment to keep the mice around. However, mice don't physiologically match up with the Alzheimer's progression as well as humans do. Kind of a similar story with apes and monkeys. Apes physiologically and genetically are way more similar to humans than Degus are, but interestingly, they don't quite show the same progression in Alzheimer's that Degu and humans do, and also apes are even more of a commitment to taking care of than rodents like Degu or mice. So for every animal model, there are pros and cons, there's drawbacks and things that don't go great, but again, it's more ethical than using humans. Usually they're very, very well cared for throughout their entire lifespan. But yeah, I just think it's interesting that in Alzheimer's specifically, the most similar model to humans are these little guys.